Hello, I'm Steve Cousins. I'm from the University of Maine system. I don't give many talks and I don't create many presentations, so it's definitely not professionally done. Bear with me. But I'm going to talk about our use of Ceph at the University of Maine system. I live in Maine, and I've been working as a computer professional for a quarter of a century now. 20 years at the University of Maine system. 12 years as an HPC administrator, and I also previously did some work with the Ocean Modeling Group using HPC. There was a bit of overlap there, so I also have 2 young kids play hockey. As you can tell, I'm from Maine, famous for a few things, lobster, of course, and mosquitoes as well. Have you been to Maine? Anybody? People know where Maine is? I used to live in California, and I told people I was from. Excuse me? Yes, well, it was cold when I came in here too this morning, or yesterday. I was surprised. But some people in California, when I said I was from Maine, they said, "That's in Canada, right?" So I'm at the University of Maine system. The system is made up of 7 universities. The main research campus is in Orono. It's actually a fairly large state. University of Southern Maine is Portland. So we have data centers in Portland and Orono. All of the research computing is done in Orono, and the backup is in Portland. And so I work in what's called the Advanced Computing Group. We do the research computing for the system. We started at the Orono campus back in around 2000. Actually, it was before I started working there. I was working as an oceanographer, and using the Beowulf cluster that they created, as well as anything else we could use around the country. We've got a couple of Army grants to build clusters. Okay. Got a couple of Army grants to build clusters, and then they handed them off to us. We retained ownership. They retained ownership, but we were able to use them, so we got quite a bit of use out of that. In 2012, the system decided they wanted to be involved in research computing, so they basically took us, and we became system employees. And now we have cloud computing capabilities, as well as storage and backup for departments and groups. And we offer data management plan help for people writing grants and things like that, and methods for archiving data and presenting data for researchers. It doesn't seem to be. So we have a fairly modest HPC system. In 2012, we transitioned away from the Apple cluster, got a Penguin cluster about the same size, and then since then we've built it up. So we've got about 3,000 cores. We have about a petabyte of storage, and we have a Lustre system. But all our storage right now is NAS storage, ZFS storage, and so, sure. A little bit about us. So we're a fairly small group. I just put this up there just to show. I'm the only supercomputer administrator, so I manage the HPC system. as well as all the storage. And we have cloud administrator, data person, and then outreach. Cyber infrastructure engineer kind of bridges a few things, outreach and some HPC stuff. So as I was saying, we currently use these ZFS servers. We have 3 of them in Orono, 3 of them in Portland. It works pretty well. That's with primary storage and backup. It's over 2 petabytes, but it's as we need to scale up, as we're doing it now, we just keep on adding servers, and it increases complexity and potential for problems. So in the past couple of years, I've been looking into ways to make it more scalable, more easy to manage for a small group like ours. And so for all these reasons. So we're also State University, don't have a lot of money. All of our hardware and everything is we get through grant money, which is harder and harder to come by. So rather than trying to build a brand new huge system to replace what we have, we're trying to phase into something new and hopefully reuse some of our old hardware. So we've used Ceph in our cloud system as the basis, the storage for the cloud system, OpenStack system. So we have some familiarity with it, but up until last year, the Ceph file system really wasn't usable for real. So I never considered it. Then I heard that the Ceph FS was ready for prime time, and SUSE was implementing it in their SES software, so I looked into that. We started talking with Paul Augustiniak and Alejandro Bonilla about it, and went from there. So decided to go for it. We thought we decided we did want to go with Ceph FS. I talked with, since we're at HPC, Ceph FS really hadn't been in the HPC side of things, but I talked with some people at the Federal Reserve in Kansas City who had been using that, and I got confidence that we could go down that route and make it work for ourselves. We could either do it ourselves or buy a prepackaged system, and based on pricing and the amount of time that it would take to do it from ourselves with a small group, we decided to go with SUSE. They had pretty competitive pricing for education at least. And so we were happy with that. So we decided to go forward with it. Basically been in the process of testing it for the last year. Part of that was we wanted to reuse a lot of our hardware, but we knew we had to buy some file servers to attach to some storage. Just the file servers we had weren't configured in an optimal way for the type of system that we wanted. So we, with Alejandro's help, we deployed it, and actually deployed it a number of times as we tested different things. SUSE has been very easy to work with. It's been a long process, and they've kept with me, and they've been very helpful in figuring out what hardware, what configuration we want to get for the performance we're looking for, which meant metadata pool with decent performance, and journals, how many SSDs we need per server to get the performance we want. And we like the cost model. It's per server, so instead of a capacity-based license, we found that we could build larger servers and reduce our costs that way, which fit in with us anyway because we want to build up large capacity. We're looking to go to 2 to 3 to 4 petabytes, and using the servers that we're going with 36 drives now. That seems doable. And they've been really good about asking for input, and some of that input does actually seem to make its way into future products. So they're very helpful that way. So what we've gone with right now, what I test with 1 master node, 3 monitor nodes. We've got two metadata servers, and then we started out with for the test with 4 OSD nodes, and then the test system has these 42 drive systems. It's actually an 84 drive system that we've partitioned into 242. So we don't really want to use that in production because of redundancy, but for testing it's been good. We use 7 240 gig SSDs for the journals, and so 6 per data OSD drive, and then in each server we also have 2 480 gig SSDs for the metadata pool. We have a combination of InfiniBand and 10 gig. I'll tell you a little bit more about that in a minute. Primarily that's because we have 2 sites, one in Portland and one in Orono. They're about 100 miles apart, and I wanted to test to see what it would be like to have 2 OSD nodes up in Orono, 2 OSD nodes in Portland. Portland does not have InfiniBand, so we've got a Mellanox InfiniBand 10 gig bridge, and we have dedicated fiber between the sites, and without a router in between, the latency is under 4 milliseconds. So everything made it seem like that it would at least work. We just don't know what the performance would be like. So we're currently testing that. It's an ongoing thing. Some things work fine. Some things we still need to tweak. There are a number of things with metadata caching that we think will help improve some performance. There's some things in the future that we want to explore. I just got more here. So one thing I heard about yesterday, I was telling Alejandro about, was the cache tiering. That might help us, where we could cache data in Orono and offer better performance, and then offload it to both sides. But he was saying that really isn't ready right now, the way it is. So we're trying to figure out whether we can live with that latency. If not, we'll bring everything back up to Orono and do it that way, and then have another type of backup down in Portland. The whole idea of splitting it is for disaster recovery, just so even though we won't really be using it down in Portland, we will have another copy there. And it simplifies it to have one system to manage. So that's my hope. But if it doesn't work out, we'll just bring everything up. Like I was saying, there's still some things we can tune. We did get a grant to be able to add some more storage. So in the works, we have 4 more of these 36 drive systems that are on the way, and we'll be adding those into the system. Eventually, once we get it in operation, we're planning on using this also for the OpenStack backend data for our next version of the cloud system. Thank you, Alejandro, for all. He's been very patient. He's do you mind if we completely redo it again? And he gets on and he re-implements it. And David Byte has been very valuable as well. So they both help to figure out what the optimal configuration has been. And so far, it's been working really well. And thank you. And I don't know if you have any questions.